Hello, this is Xtal. In this tutorial, we will use TouchDesigner to create a particle visual effect that mimics the motion of light and energy being drawn in. We will explore how to precisely control the flow and movement of particles to visually express the accumulation and dispersion of energy. This tutorial is designed not only to guide you through the steps, but also to help you understand and apply the core concepts of TouchDesigner. By following along carefully, you will learn the principles behind controlling particle motion and build a strong foundation for creating your own unique visuals. Let's get started. We will import the audio file into TouchDesigner and process it within the CHOP network to extract meaningful data. This data will then be used to dynamically control the movement of particles, creating a real-time visual effect that responds to sound. Next, bring in a renamed CHOP and connect it to the audio data. In the To field, enter Chan1 and Chan-R to define the channel names, making the data more intuitive to use in subsequent operations. Add a delay CHOP and then set the scope parameter to Chan1 to apply a delay to that specific channel. This will introduce a time offset, allowing the particle movement to respond in a more natural and dynamic way. Next, set the max delay value to 1 to limit the maximum delay time to 1 second. Add an audio filter CHOP, then change the cutoff units to frequency and set the filter cutoff value to 40. This will filter out frequencies above 40 Hz, allowing you to extract the low-frequency components of the audio signal, which will create a more focused response in the particle effect. Copy the audio filter CHOP by pressing Ctrl+C and Ctrl+V to create 8 instances, then set different filter cutoff values for each. This will allow you to filter different frequency ranges of the audio signal, creating unique particle responses based on various frequency bands. Next, use a merge CHOP to combine all the audio filter CHOPs into a single stream. This allows you to efficiently manage and process the various frequency bands of the audio signal within one network. Now, connect the shuffle CHOP to the merge CHOP and set the shuffle CHOPs method to sequence channels by name. This will arrange the channels sequentially based on their names, ensuring that the data for each frequency band is organized in a continuous order without altering the channel sequence. This step makes it easier to process the filtered audio signal efficiently, allowing each channel to be handled in sequence, which is particularly useful when managing multiple audio channels within a unified flow for subsequent operations. Bring in a null chop and a chop 2, then drag and drop the null chop onto the chop 2. This step ensures that the null chop is used to pass data reliably, while the chop 2 allows for the transformation or forwarding of the signal to the next processing stage. This setup helps maintain efficient data flow and makes it easier to work with the data in subsequent steps. After adjusting the start and end positions in the chop 2, you will set the channel scope and attribute. For the channel scope, you will typically input P0 to specify the position channel and N0 to define the normal channel. This allows you to target specific data channels for further manipulation. In the attribute field, you will enter values such as position, velocity, or color, depending on the type of particle effect you want to achieve. For instance, setting position will control the spatial movement of particles, while velocity can define how fast the particles move and in which direction. Similarly, color can be used to control the visual appearance of each particle. By configuring these parameters, you ensure that the chop 2 processes the data accurately, applying the proper attributes to each particle, and creating a dynamic and controlled visual effect based on your desired outcome. After connecting the chop 2 to the particle SOP, set the channel scope in the chop 2 to Chan, Shaner, Chan, Shaner. This configuration allows you to map data from specific channels directly to the particles. Here, Chan and Shaner refer to the audio-filtered data channels previously set up. The Chan channel can be used for physical attributes like the particle's position or velocity, while the Shaner channel can control visual attributes like the particle's direction or color. This setup enables the transformation of audio signals into particle movements in real time, allowing you to control the position and behavior of the particles based on specific frequency bands. By treating each channel separately, you can create dynamic, frequency-responsive particle effects. Now, let's adjust the settings in the particle SOP to create the effect of particles being pulled inward. By experimenting with various parameters such as speed, direction, size, and lifespan, you can fine-tune the look and feel of the particles. Follow along with the tutorial video and try making small adjustments to each parameter. For example, altering the velocity or lifespan, or adjusting the particle count, can significantly impact the behavior of the particles. Through this experimentation, you will be able to create a refined effect where the particles appear to be drawn into energy or light. Bring in a torus SOP to connect to the particle SOP. The torus serves as a useful shape for defining the starting point or path of the particles. By using this toroidal shape, you can guide the particles to move along a circular path, allowing for precise control over their flow in 3D space. You can adjust the size, rotation, and segment count of the torus to create a dynamic range of movements and behaviors for the particles. You can connect a transform SOP to the torus SOP to manipulate the torus's position, rotation, and scale. The transform SOP is used to adjust the transformation properties of an object, allowing you to dynamically set the torus's translation, rotation, and scaling. This enables precise control over the torus's placement and appearance in 3D space. Adjust the uniform scale in the transform SOP to modify the overall size of the torus. Next, set the Rx value in the rotate parameter to 90 to rotate the torus along the x-axis. For the Ri value, input abs_time.seconds times 0.9 to create a continuous rotation effect over time based on the absolute time in seconds. This setup will ensure that the torus smoothly rotates around the y-axis, adding dynamic movement to the particle system. Now, let's recreate the particles similar to what we made earlier, but this time we'll scale them down to create a more dense and rich particle visual when combined with the previously created particles. This will add more complexity and depth to the overall effect. Follow along with the video and try adjusting the particle sizes while maintaining the overall composition to achieve a fuller, more dynamic look. Connect the previously created transform SOP to the particle SOP, and then sequentially link particle 1 and particle 2. This step allows you to combine and control multiple particle systems, layering their behaviors to create a more complex and dynamic visual effect. By connecting them in this order, you ensure a smooth integration between the transformations and the particle dynamics. Connect a geocomp to particle 1. The geocomp will serve as the 3D geometry container for the particles, allowing you to define the appearance and behavior of the particles using 3D various SOP. By linking it to particle 1, you will be able to visualize the particle system in 3D space, while also applying any transformations or materials to enhance the overall effect. This step integrates the particle dynamics with the geometry, providing more control over the final visual output. Adjust the scale of the geocomp to fine-tune its size. This allows you to control the overall proportions of the 3D geometry used for the particles. By modifying the scale, you can ensure that the geometry aligns with the desired visual effect, making the particles appear either larger or smaller depending on the look you're going for. Fine-tuning the scale gives you precise control over how the particles interact with their environment in the 3D space. Connect a constant top to the geocomp to change the color of the particles. By adjusting the color in the constant top, you can dynamically alter the atmosphere of the particle effect. This allows you to modify the visual mood of the particles, making them appear warmer, cooler, or more vibrant, depending on the color settings. The color adjustments will directly influence the overall feel of the effect, enhancing the connection between the audio-driven motion and visual presentation. Repeat the process you applied to geocomp and constant top for particle 1 and connect the same to particle 2. This ensures that the same geometry and color settings are applied to the second particle system, maintaining consistency across both particles. By doing this, you create a unified visual experience for particle 1 and particle 2, where both systems share the same aesthetic adjustments, allowing for a more cohesive and dynamic particle effect. Next, bring in a camera comp and adjust its settings. The camera comp allows you to control the perspective and view of the 3D scene. By fine-tuning the camera's position, rotation, and field of view, you can create the desired framing and depth for the particle effect. This step will help to ensure the particles are viewed from the right angle, enhancing the overall composition and making the effect more immersive. In the camera comp, go to the window roll parameter and input abs time, seconds times 30. This will create a continuous rotation effect for the camera based on the absolute time in seconds. By multiplying the time by 30, you set the camera to rotate smoothly over time, giving a dynamic and evolving perspective to the scene. This effect helps to add motion and depth to the overall composition, making the visual experience feel more immersive and engaging. Bring in a second camera comp and adjust its settings. The Cam 2 will provide an alternative viewpoint for the scene, allowing you to create a multi-angle perspective. Fine-tune the position, rotation, and field of view of Cam 2 to achieve the desired effect and ensure it complements the primary camera. This will add more depth and variety to the visual experience, offering multiple angles to view the particle system. Bring in a render top and connect both Cam 1 and Cam 2 to it. The render top will allow you to render the scene from the perspectives of both cameras. By inputting both cameras into the render top, you can switch between the two views or even blend them, depending on your desired output. This setup gives you the flexibility to create dynamic visual effects, incorporating multiple angles and perspectives into the scene. Next, bring in another render top and connect only Cam 2 to it. This will render the scene solely from the perspective of Cam 2, giving you a separate view of the particles or scene from that specific camera angle. By having two different render tops, one for Cam 1 and one for Cam 2, you can create a more complex and layered visual composition with the option to combine or transition between both perspectives. Connect the out node to the render top. This will output the rendered scene, allowing you to view or use the final composition in your project. The out node serves as the final output node, sending the rendered image or scene to the display or to other parts of your project for further processing. This step ensures that the visual output from the render TOP is visible and ready for use. Next, connect an anti-aliasing node to the out node and change the anti-aliasing setting to Ultra. This will improve the quality of the rendered image by smoothing out jagged edges and giving a more polished, high-quality look to the final output. Setting the anti-aliasing to Ultra ensures a finer level of detail and smoother transitions in your rendered scene. Next, we will use image filters to create two different versions of the particle effect. The first version will use the feedback filter from the left palette to achieve a dreamy, ethereal visual. The second version will use solarize and radial blur to create a glowing effect where light expands and shines. Follow along and experiment with how these filters can be applied and adjusted to achieve different looks for your particle effect. Each filter will bring a unique style to the visual, so feel free to tweak the settings and explore their potential. In the feedback base, input seconds as the unit of measurement. This will set the feedback effect to be based on time, ensuring that the feedback evolves smoothly over time. By using seconds, you synchronize the feedback loop with the overall timing of your scene, allowing for more dynamic and controlled visual effects. From the left palette, bring in both the feedback and solarize filters. Adjust each filter to explore how they affect the visual and experiment with different settings to achieve the effect where light expands and radiates. The feedback filter will create a trailing, repeating effect that can simulate light emanating and dispersing, while the solarize filter can add a high contrast, inverted look, highlighting the light and enhancing the glowing effect. By experimenting with the values and parameters of both filters, you can fine-tune the visual to create a unique interpretation of light spreading and glowing, adding complexity and depth to the particle effect. Connect a bloom node to the solarize filter to enhance the glowing effect. The bloom effect will create a halo around the bright areas, intensifying the light and making it appear even more radiant. Adjust the threshold, intensity, and other bloom parameters to fine-tune how the light spreads and glows. This will give your particle effect a more luminous and ethereal look, emphasizing the light expansion from the solarize filter. Experiment with these settings to find the most striking glowing result. To enhance the glowing effect, connect a radial blur node to the bloom node. The radial blur will create a blur effect that radiates from the center, simulating the spreading of light. By adjusting the parameters such as center, blur amount, and quality, you can control how the light appears to expand outward, giving it a more dynamic and organic feel. The way the light spreads will change depending on the input values, so experimenting with different settings will allow you to achieve various intensities and patterns for the light. Apply this effect to different particle shapes and see how it reacts. This will allow you to create a wide range of particle visuals, each with its unique glowing and light dispersing effect. Have fun experimenting with these adjustments and see how the different particle types react to the combination of bloom and radial blur. Finally, to make the particles stand out more clearly, let's use a black background. This can be easily achieved by connecting an over node and a constant node. The constant node will provide a black background, and the over node will composite the particle effect on top of it. This combination ensures that the particles are more vivid and noticeable against the dark background. Personally, I enjoy using the over node for compositing because it gives you full control over how elements are layered, allowing for smooth and seamless integration of visual effects. With the black background in place, your particles will be sharper and more visually striking, enhancing the overall impact of the scene. Once you're ready to output the video, use the Movie File Out node to export your final composition. This node allows you to render and save the particle effect as a video file, making it easy to share or use in other projects. Set the desired output resolution, frame rate, and file format, and then connect the final composition to the Movie File Out node. This marks the completion of the particle effect implementation. With the video output prepared, you're all set to render and share your creation. With that, we've created a visual effect based on the theme particle effect, capturing the motion of light and energy being drawn in. The creative process is always challenging and at times difficult, but the growth and discoveries we make along the way hold endless value. I hope this tutorial has helped you learn new techniques and inspired you to enjoy the process of creation. Always keep experimenting, challenging yourself, and developing your own unique style. Creation is an endless journey, and I hope you find true fulfillment as you continue on your path. Thank you.